Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, find common characters. So basically we have an array of words and we want to return an array of all the characters that show up in all of the words, so sort of in the same occurrence in every word. That's what they mean by including duplicates, and we can return the answer in any order. So for example here, if you take a look, the example here, we have two L's here, two L's here, two L's here. So we definitely need to have two L's, and then we have one E in every word. Sorry, here actually. But then the other ones, for example, A is not in the last word. And so the only ones that are common are these three. But pay close attention here that L we included it 2 times because it appears 2 times in every word, right? So that's the idea. That's what we need to do. And so since this includes duplicates, that immediately means we can't use a set, because sets will dedupe the number of elements. So what we can do is use a counter, because a counter or a hash map to keep track of the number of elements, and we can either take the min or take the intersection. What do I mean by that? So let's take something like this here. So if we have something like this, then what would be the occurrence for the first word? So when we do the first word, we'd have one B, 2 L's, and then one A. Okay. Now, what should we do when we get to the second one? Well, we can either take the min of the number of occurrences, because at the end of the day, what we are looking for is the common occurrences of characters. And so we could take the min. So this one is 2. So if you take the min, it stays here. And then A, the min, so 1, since it occurs once here, and then take the min for the number of occurrences of B, which is 1, and then take the min for the number of occurrences of E, which is, sorry, I didn't add E here, which is 1 as well, right? And so it still stays the same as this. And then if we go here, R, it's not there, so initially if it's not here, we can consider it to be 0. So the min is still 0, so we don't need to change it. O, it's already at 0. 1, the min is still 0. L, 2, the min is still 2. E, 1, the min is still 1. But A is not here, so it's 0, so we need to remove it, or we need to set it at 0. And then same thing for E is at 1, so we keep it, the min is still 1. Right? So that's one way to do it using the min, but using the min is going to be a little bit slightly complicated, because as you saw, for letters that are not present, let's say C, for example, let's say O here, that wasn't present before, but is present here, we need to consider it, but as 0. So we need to loop through all the lowercase letters. Okay. So we could do that, but actually a more efficient way is just to take the intersection for the counter. So if you are using Python, then you could just have a collection and use the intersection of the first one with the second one. That will only take the minimum, okay? But let's actually just do the first solution and then optimize from there, okay? So the first solution using the min approach, let's do that, and then we can go gradually to a better solution. So first we need to start from somewhere. So like we did here, we started from this first word, so we can just start from there. Now I'm going to use a counter in Python, but you can use a hash map. So we start from the first one, and then we need to go through the words, the rest of the words, and then we have this, which is going to be a collections.counter for W, for this word, right? Just like I did here with iterating. Just like we did here with iterating through the word, letter by the word occurrences, we do the same here. Now what do we need to do? We want to take the min, but we want to do for all the lowercase letters, right? We are told here that we only have lowercase letters. And why we are doing lowercase letters? Because there may be a letter that is in the first word that is not in the second word, or vice versa, right? And so here we do string, not ASCII, lowercase, and then we just take the min, right? So the min, so this is of word, let's call it, the min of the remaining, the intersection one, we are going to take the min of what we have from the previous words and what we have in this current word. Let's call it word C, okay? And now when we do this, right, if the character is not present in this current word, we will remove it from this one, or it will be set at 0, right? And so at the end we will be left with only the common values. So in this case we'll be left with 2 L's and 1 E. And so we just need to construct them and then return them. So how do we do that? Well, we just go through all the letters, or we could do like items like this. We can actually just go through all the letters that we have and then just multiply that by the number of occurrences of that letters. So for example, for L, the number of occurrences would be 2, and so we'll multiply this one by 2. We'll multiply L by 2. So if we run this, it should work, except this is, let's remove this, run it again, looks good. Let's submit, and that works. Okay, so now let's do what I said about, instead of using the minimum, we can actually use intersection, which gives us the same thing. I did it this way so that you have a mechanism that works with the hash map. You can use it in Java, for example. But if we want to use a more like Pythonic solution here, we can just take the intersection. The intersection will do the same thing. So to do that, well, we can just take occurrence and get the intersection with this here. That should give us the exact same result, and it does. Okay, now we can put this here, put that here, we should be good. Run this, submit, and it does pass. Okay, okay, so now how can we improve this a little bit more? The first thing is that this here, this logic that we are doing here, there is already a Python function that can do that for us. So that's why you should always try, when you are using a language, try to learn the libraries. There is collections in Python, there is collections elements. So collections elements, if you look here, elements, it returns an iterator over the elements, repeating each character as many times as the counter of its occurrences. So for example, if you take this, it will repeat A 4 times, repeat B 2 times, and this one 0 times, and this one, since it's negative, it will not be, it will be 0 times, okay? So we can actually use that because that's exactly what we need, right? And so here, instead of doing this manually, we can just take the occurrences and use elements. Okay, and that looks good. Let's submit. That looks good. Okay, now what is this? If we look at this one as well, it's just going through the words, starting from the first one and doing an operation which is AND. Now what operation or what sort of function does this for us? That's exactly what reduce does. Reduce takes a first element and then takes an operation and then gives you the cumulative results of that operation on all the elements, right? That's exactly what reduce does. And so our first element here can be just the word. It can be just the other variant, by the way, of reduce is you don't give it the first element, you just give it a collection and an operation and give you the cumulative result of that operation on all of them. An obvious example of reduce is sum, right? Where you take a collection and the operation is just add, and that gives you the sum of all the elements because it applies the operation on all the elements. So that's exactly what we are going to do here. Our operation is AND, and then our collection is just the list of words. So what we can do is just do reduce with AND. Now AND in operators in Python, it's called IAND. If we look at operator, sorry about that, it's here, IAND. So it's Basically, it is equivalent to doing A and B, and then having the result be in A, and that's exactly what we need for our case, our reduce here. So let's just call it IND operator. So this will come from the operator library or the operator class. And then now what we can do is just pass the list of words. But remember, we don't need just the list of words. We need to do something like, we need to apply the counter function. So we can use either something like this, W, like this for W in the list of words, like this. Or the same way you can do this, you could use a map. So you could do map. We want collections.counter on the list of words, and then when we reduce it, we can have that in occurrences and then return it. Okay, now that should replace this. We can just remove that. I think we may need, okay, so that looks good, looks exactly the same. Okay, and so we can just move this up here, elements, and just return this. Okay, I know this may be not readable, but we can still like have the dot elements at the in a separate line, but this is a good use of reduce, I think. Okay, let's submit, and this passes. Okay, yeah, so that's pretty much it what I wanted to show for this problem. Thanks for watching, and see you on the next one. Bye.